in terms of the E1 problem for the CP class, like I said, we kind of struggled a lot with that. The E1 problems are kind of weird because I give you some different things I normally don't give you. So if we're looking at an E1 problem, they look a little different just to kind of begin, because in many of them, although not all, but in many of them, I give you a time. I say something like the time is, I don't know, 10 seconds, okay? Normally in a problem, I don't give you the time. You kind of have 3 things in the y direction, 2 things in the x direction, you find time, you swap time, and you play with the other side. In this problem, I've given you time, which is a little wonky. So if I kind of set up the xy, same thing as always, vi, vf, delta whatever, acceleration and time. We play our whoosh, 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 whoosh game. We know the negative 9.8. We know the 0. And in this case, we have the time, so we can put in 10 seconds into both sides. Now, let's try a problem that I kind of gave in class a little bit, or a similar one. Let's pretend that you're standing on the top of a very tall cliff, and you throw something out at an angle. Okay, so you're just like, you're at the Grand Canyon, and you're like, I want to give the Grand Canyon a bagel. So you throw a bagel out into the Grand Canyon. Okay, something will eat it, I guess. That's littering. Don't do that, but you did it, so time to pay the fine of physics. Let's say we know the angle we throw it out. Let's say we throw it out at like 25 degrees. Okay. Now, in a problem like this, you would have the angle, which is one thing, the time, which is the second thing, and then I'd say something like you were, I don't know, 40 meters off the canyon floor. Okay? Which means that as this bagel begins its descent, bagel, it fell 40 meters. So we know delta y, negative 40. Okay? If you look at this setup here, that's the only information we know. But we still have 1, 2, 3 things in our y column. They're not the normal 3 things we have in our y column, but we still have 3 things. Now, if we consider our best friend and we look at the equations there, with 3 things I can solve for other stuff. I can either solve for VI or VF. Except on our best friend, there is no way for us to solve for VF without VI. So let's go and solve for this initial y velocity. Okay? Now, if I solve for this initial y velocity, I'm actually using equation number 5, as in delta y equals the initial y velocity times time plus 1/2 t squared in the y direction. And if I go ahead and plug everything in here, I'm going to get negative 40 equals what we're looking for, VIY times 10 plus 1/2 of negative 9.8 times 10 to the squared. Now I gotta solve this. Okay, whatever, let's do it. If we take 10 squared, that's 100. About half of 100 is 50. 50 times negative 10-ish. This is about negative 500. This is VIY times 10 equals negative 40. I add 100, or I add 500 over to the other side. So adding 500 gives me, gives me 460 over here. 500 plus negative 40 equals VIY times 10. And then if I divide by 10, I find that the initial y velocity is approximately 46 meters per second. Give or take, because I rounded that a little bit there. It's a common thing to do if you're doing stuff on the fly. So we know the initial y velocity now is 46 meters per second. And if we wanted to, we could find the final y velocity. But in this problem, let's actually try to find this. Let's try to figure out how far away this thing actually landed. How far did you get that bagel into the Grand Canyon? What are you going to be feeding? So if I look at this here, okay, I got more y information, but I need more x information. In the x direction, the only equation I ever have is equation number 1 for us, which is delta x equals a velocity in the x direction times time. I don't have velocity. I have time, and I'm looking for this delta x. So I need to get this initial velocity in the x direction somehow. I have no way to do it. So we think back for a second and recognize we do have a way. And it's right here in the initial launch of our bagel. We knew we kicked this bagel off at 25 degrees. And we know that this here was the actual velocity in which we threw the bagel. What we solved for, that 46 meters per second, that was VIY. And what we're trying to grab real quick is we're trying to grab the x velocity, which just so happens to be this side of the triangle. Since we know this is equal to 46 and this is the opposite side, while the x side is our adjacent side, and we know the angle, we can play a little bit of SOHCAHTOA here. If we do this, we can say that the tangent of 25 degrees, because remember, it is the angle of which we're looking at, and since we have opposite and adjacent, that's TOA, that's tangent. The tangent of 25 degrees equals the opposite side, that was our 46 meters per second, divided by the adjacent side, that was our x velocity. If we want to solve this, we need to pull little swapsies here with these two. Technically we're multiplying each side by vx and dividing each side by the tangent of 25. If we do that, we get vx equals 46 divided by the tangent of 25 degrees. If we work out what is 25 divided by, or 46 divided by the tangent of 45, or 25, 46 divided by tangent of 25, we get a number, if I could ever get one. Let's see, 46 divided by 0.4666. We get an x velocity of about 98 meters per second. If we have an x velocity of 98 meters per second, and we know that a velocity times time gives us a range, gives us a distance, we could simply say that 98 meters per second times the amount of time, 10 seconds, equals 980 meters. And that's how far you just threw a bagel into the Grand Canyon. Pretty impressive, if I do say so myself. You got quite an arm there, kid. Okay, but that's how we can go about this problem. It all comes back to this right here, a velocity triangle, and that's kind of a tricky thing to remember. So that's one way we can do an E1 problem. We're kind of given a bunch of stuff, we're using a velocity triangle to solve it. Another kind of E1-esque problem that we can kind of play with is